What's going on, guys? Tom here, and in today's video I'm going to be teaching you how to create an inventory and item pickup system in the Godot engine. Before I start, if you're new to this channel and you're looking to begin learning game development, I'd love it if you consider hitting that subscribe button. I release new content every week to help you improve your game development skills, and I'd love to have you become part of this fantastic community. With that being said, let's get started. Okay, so you can see I've got Godot open here, and I just have a 3D scene open with a character. It's a third-person character. Now, it doesn't really matter what base you're starting from here. The core concepts will still apply, and you will still be able to use this system in any game you want to create. So this tutorial is not really focused on creating the third-person controller. This is more about creating a generic inventory and item system that you can apply to any game that you want to create. I'm just going to be using this as a base, but hopefully you have something to work on. If not, you can follow my third-person controller tutorial. I'll leave that in a link below. And you can also follow my first-person tutorial as well. That will work perfectly fine too. I'll also leave a link to that in the description as well. But for now, let's get started with creating this inventory and item system. Okay, so the first thing we're going to do is define our item resource. Now to do that, we're going to come down to our file system. Let's right click on Res and click on Add New Script. And we're just going to call this item.gd. Now where it says inherits from node, we're actually not going to inherit from node at all. We're going to click on this little hierarchy button here, and we're going to search for resource. Now you'll get a bunch of different things here, which are various different resource types that are built into Godot. We're actually going to create our own, so we're going to inherit from the base resource class. Let's create that script and let's fire open our script editor. Let's double click on the item.gd, and now we're ready to define what variables we want to store on our item. So you could have as many as you want. I'm just going to add a few for default, and then we will add a few extras just to show you what sort of things you could do with this. So let's delete all of this. So we're going to say class_name item resource. Okay, and that just means that we can reference this in Godot as a item resource resource. Okay, so we're going to export a few variables here. We're going to export a var called name, and this is going to be a string. We're going to export another var called stackable, and this is going to be a boolean with a default value of false. And we're also going to export a variable called max stack size, and this is going to be an int, and we're going to default this to 1. So name is obviously going to be the name of our item. Stackable is going to determine whether or not this item can be stacked multiple times in a single inventory slot. And max stack size is just going to determine how many items can live in a single slot before that item goes into a second slot and you start accumulating a new stack. What I will do is I'll export a few more variables here just to show you the kinds of things that you might expect to see on a item resource. So let's put a little comment here and let's just say examples of more properties we could store. And let's do an enum for starters, and we're going to call this, we're going to have a named enum, so let's call it enum item type. Now again, all of these things that I'm adding here we're not going to use in today's tutorial. This is really just to show you what you could add to this and how it would be reflected in the inspector. So let's add a few things to this. Let's add a generic item type, perhaps a consumable, quest item, and maybe a piece of equipment. Oops, equipment, there we go. And let's export a variable for that. So let's do export. And if we open brackets here, we can provide a inspector hint, and this will allow the inspector to determine what kind of interface it's going to give the user when they're choosing the variable's value. So let's say export as an item type, and we're just going to say var type. And let's try and add a couple more things here. So perhaps you might want to export a variable to allow you to assign a texture to this item. So we can export a texture. And perhaps this is a 3D item. Maybe you want to export a mesh as well. Okay, so these are just examples of things you can do. Of course, you could add multiple variables here like consumable, health restoration. You could add attack, defense, any sort of stats that you want this item to have, you could add as part of these export variables. So let's save this. And what we're going to do now is we're going to create a set of items. So let's come into our res folder again. Let's create a new folder, and we're going to call this items. Okay, and we're going to right click on this and we're going to press new resource. Now you can see here that it's auto-populated item resource, probably just because I've searched for that before. If you haven't, again, just search for item resource and you'll see it comes up there, item resource, and that's our item.gd script. So let's create one of those and let's call this one oak log. Okay, you can call it whatever you want. I'm just going to go with oak log. Let's save that, and then if we open our items folder, you'll see if we double click on this oak log and come into the inspector on the right hand side, you'll see here now that inside script variables, we have all of the exported variables, just like you would in any standard GD script file, except this is now a saved resource on our hard disk. It's saved as an oaklog.tres file, and that means we can basically load that file in and save it as well at runtime, which is really, really handy, and I'll show you what that means for us a little bit later on. So for now, I'm just going to come through here. So we're going to say oak log. Okay, so I've given this a name. So oak log, and it's stackable, and we've set its max stack size to 5. Again, these are the properties that we defined over here on the left. We're not going to use these in today's tutorial, but it's just to show you how the inspector would react if you had these sort of properties available on your item. So you can see here that when we use a typed, a named enum, that we get the options here. So generic, consumable, quest, and equipment. And if we had a texture and a mesh, you can see that we get a very similar interface to what you would do on a standard node in Godot. So for example, you can assign a image texture, and for the mesh, you could assign, for example, a cube mesh. I'm just going to clear those out for now because we're not going to be using those in today's tutorial. Okay, and let's save that. And now let's also create a second item that isn't stackable. So I'm going to right click on this oak log. I'm just going to press duplicate, and I'm going to call this something like magic orb. Okay, so let's double click on that one. And you can see it's got all of the variables duplicated from the old one. So let's give it a name, magic orb. I don't know how I'm spelling it like that, but there we go. Stackable, let's turn stackable off. And because stackable's off, max stack size doesn't really matter, but let's reset it to 1. Just to be clear. Okay, cool. So we now have, oops, let me just delete that one. We now have an oaklog.tres file and a magicOrb.tres file. Brilliant. So now what we're going to do is we're going to create an item database that is going to loop through all of the files within this items folder and add it to a database that we can access within our game at runtime. To do this, I'm going to create a folder. I'm going to call it managers. And I'm going to right click on that folder and create a new script, and I'm going to call it item database. Let's open up the item database script and let's delete all of this out here. I'm just going to save that, and I'm going to come up to my project settings. I'm going to come over to the auto load tab here, and I'm going to press this little browse icon, and I'm going to choose my item database and click on add. Now what that's going to do is it's going to auto load this script whenever the game runs. And you'll see here it's got this singleton enabled checkbox. What that's going to do is it's going to instantiate one single instance of this class, and that is going to be accessible from anywhere within our game simply by typing item database. That's really, really handy when you just want one instance of something to be running at a single time and you want access to it from anywhere inside your game. A singleton is really, really useful for that, and the auto load section of our project settings allows us to do just that. So let's close this, and now we're going to start creating this item database script. So the first thing we're going to do is we're going to create a variable to store our items in. So let's say var items equals array. So we're going to have an array of items. And now we're going to define our ready function. And inside here, what we're going to do is we're going to read from this folder here, this items folder. So we're going to loop through all of the files within that and basically instantiate them and add them to this items array. So let's say var directory equals directory.new. Then we're going to say directory.open, and we're going to give it the path to this items folder. Now we can do that by saying res / items. Okay, so that is listed here. It's quite easy to see. We've got res / items. Then what we're going to do is we're going to say directory.list dir_begin, and that's a function, so we're going to call that. And that's going to basically allow us to start enumerating through the files within that directory. Next, we're going to say var file name equals directory.getNext. That's going to get the first file within this directory. And then we're going to loop through all of these. So to do that, we're going to say while file name. So while file name has a value, we're going to say if not directory.current is dir. And basically what that's saying is if the current thing that we're enumerating over is not a directory, then we know it's definitely a file. In that case, we can say items.append. And this is where we want to load that resource. So you'll have done in the past, you'll have done something like var bullet equals load, and then you'll have passed it the path to the bullet scene, for example, or a player scene, whatever it might be. We can simply use that load function directly here. So we're saying items.append, which adds a new item to the items array. And what do we want to add? Well, we want to add the resource at that path. So load, and then we're going to say res items slash, and then we're going to use a string formatter. So we're going to say %s, and we're just going to interpolate the items file name into this string. So %file name. So that's going to go through, it's going to get the file name. So it's going to get, for example, magicorb.tres, and it's going to replace that with, replace the %s with the file name, and that will load it from the directory. Okay, next what we're going to do is we are going to get the next file. So we're going to say file name equals directory.getNext again. So we're basically just doing this again to make sure that we are enumerating to the next file. And that's just going to continue looping until file name becomes null, until there's no more files in the directory. Okay, next thing we are going to do is we're going to define a function within this item database that allows us to get an item from the database based on its name. To do that, we're going to say func get item, and we'll give it a parameter of item name. And then we're going to loop through all of the items we have in our array and basically loop until we find one that has the name that the user's asked for. If we have found it, then we're going to return it. If not, we're going to return null. So let's say for I in items. So for every item within the items array, we're going to say if I.name equals item name, then we're simply going to return the item. And if all of that fails, so we've gone through all of the items, we've never hit this condition, so we haven't found the item, then we're simply going to return null. Let's save that, and that is it for the item database class. So we are looping through this directory here and loading every single one of the resources into an array called items, and then we simply have a function that will iterate through this item array, and it will return any item that it finds with a matching name. Okay, so the next thing we're going to do is we're going to create an inventory class that we can add to our player as a resource, and this inventory class is going to be responsible for setting items on the player, getting items that the player has, being able to add items to that player's inventory, and it's also going to emit a few signals as well. Actually, it's just going to emit one signal that will let everything know, all the other scripts in our game, let them know when the player's inventory has changed. And that's going to be useful for things like updating an inventory screen, for example. To do that, we are going to create a new script. So let's add a script underneath our player folder here. You might not have a player folder. If you don't, that's absolutely fine. Add it wherever makes sense for you. I'm just going to expand this player folder, right click and create a new script. I'm going to call it inventory.gd, and I'm going to open it up. Let's delete all of this. I'm going to give it a class name. So I'm going to say class name inventory. And I'm going to define that signal that I mentioned before for when the inventory gets changed. So let's say signal inventory changed. And I'm also going to have a private variable, export var underscore items equals array. And it's also going to have a set and a get function. So let's say set get. Now you might not have seen this before. This basically allows us to define inline a setter and a getter for this particular variable. So let's say set get set underscore items. That's the name of our set function, comma get items. That's the name of our get function. Now you might be wondering, if I'm trying to make this as a private variable with this underscore naming syntax in front, just like we see on func underscore ready, why am I exporting it here? Now the reason for that is because we are going to create this as a resource. Now, actually, I should have extended this from resource, so let's quickly change that there. And we're not extending this from node, we're extending this from resource. And we want to be able to save this inventory as a resource to the file system. Now, in order to do that, in order for the items to actually get saved, we need this export keyword on this items array itself. If we don't have that, the items simply won't get persisted to disk, and when we try and load it again, we'll have no items in our inventory. So that is the reason we're using the export keyword there. Okay, so let's define our set item function that we hinted to above. So func set item and new underscore items. Actually, I've just realized here that this should say set items and get items. Okay, so set items. And then what we're going to do is we're going to say underscore items equals new items. And we're also going to emit that inventory change signal. Someone has set a brand new set of items on this inventory, so we want everyone to know that our inventory has changed. So let's say emit underscore signal. Let's give it the name inventory changed. And we're just going to pass a reference to this inventory resource itself, so that whatever is receiving this signal can directly access the inventory and see exactly what has changed there. Okay, so let's create the function for get items. This is not going to take any parameters, and we're simply going to return that array directly. So return underscore items. So now let's define a function that allows us to get a particular item from this inventory. So let's say func get item, and we'll give it a index property. And again, all we'll do here is return our items, but this time we will return it at the index that's passed, and that will return a single item from this items array. And finally, we are going to add a function to allow someone to add an item to this inventory. So we're going to call this func add item. And all we're going to take here is an item name, item underscore name, and a quantity that we want to add. So we're going to need to do a few things here in this add item. First of all, we want to make sure that we're not passing a negative quantity. We don't want to be able to use this function to remove items. That's probably not the best thing to do. We would probably add a separate function to be able to do that. So this function is purely going to focus on adding new items. So we're going to make sure that the quantity that the user passes in is above 0. So it's a full number, whole number. And we're going to say if quantity is less than or equal to 0, then we're just going to print something that says, hey, we can't add a negative number of items. And then we're simply going to return out of this function. That was an error. You can't add less than 0 items, so there's nothing else for us to do here. So let's return out of the function. The next thing we're going to do is we're going to try and find the item that the user has asked for. So based on this item name, we're going to try and find that in our item database. So to do that, we're going to say var item equals item database, and this is where our singleton auto load comes in. We can simply access the item database we created here by calling it item database dot, let's say get item, and we're going to give it the item name. And what we're going to say here, let me just scroll down a little bit here. I'm going to get rid of this output for a second. What we're going to do is we're going to say if not item, so if we didn't find an item in our database with that name, then we're simply going to say print could not, oops, brackets in the wrong place. Let's say could not find item. And again, we're just going to return from this function. Okay, so if all of that has passed, we know that the user has passed in a positive quantity, so either 1 or above. We know that they have passed in an item that we have actually found in our database. So now what we're going to do is we're going to start trying to work out whether or not we have a current stack available for this that we could add it to, if it's even stackable at all, and perhaps we have to create a brand new slot for this item. We're going to do all of that logic next to add this item to the player's inventory. So first of all, what I'm going to say is var remaining quantity equals quantity. So the user's passed in 5, for example. We want to keep a count of how many items we still have left to add to the inventory. Now, the reason we're doing that is because, for example, the item that the player is trying to add, it might be stackable in stacks of 5. You might be trying to add 3, and the user might already have 4. So we need to keep track of how many we need to add to each stack and how many new stacks we need to create. So I'm just creating this variable here as a temporary variable that we'll start decrementing as we start adding these items to the inventory. Now, if that doesn't make sense right now, don't worry, it'll all become clear as we start writing more code. The next thing I'm going to do is I'm going to say var max stack size equals item.max stack size. So we're going to say the max stack size is the item's max stack size if the item is stackable. So if item.stackable, otherwise it's 1. So how many can be stacked in one single inventory slot? Well, if the item is stackable, then it's the item's max stack size. If the item isn't stackable, then it's simply 1. 1 can go in a single slot. Okay, so now we're going to check whether or not the item is stackable, and if it is, we're going to loop through every single item in this inventory, and we're going to try and find stacks that we can add some quantity to in order to meet our demand. So we're going to say if item.stackable, so if the item is stackable, then we are going to loop through all of the items in this array. Let's just scroll down a little bit. So we're going to say for I in range items.size, and that's a function, and that is going to basically get the current size of our inventory items, and it's going to loop through every single one. Okay, so we're going to say if remaining quantity equals 0, then we can break from this loop. Okay, so if we don't have any more items to add, then we don't need to carry on looping through all of these items. We know that we can just break straight out of this. Now, I understand that this might start getting a little bit confusing. Feel free to pause the video or rewind the video and watch this several times so that it starts to make a bit more sense, because this is, I understand it is quite complicated. It took me quite a few times to understand the code that I wrote the first time. The next thing we're going to do is we're going to say var inventory item equals items with the index. So we're going to get a reference to the current item that this loop is looping through. Okay, so let's say, for example, we've looped through this 3 times. We're going to say inventory item equals the third item in our array. And what we're going to do is we're going to check if that inventory item is even the same item that we're concerned with adding. If it's not, again, we can just continue straight past this loop. It's not the right item. We can't add to the stack of it because it's not the same item. So we can just bypass that straight away. To do that, we're going to say if inventory item reference dot name, and you'll see why I'm calling this item reference a little bit later on, does not equal item dot name. So it's not the same item, then we can just call continue. Continue keyword will basically say, I'm not interested in doing anything after this line for this particular iteration of this loop, so just go straight on to the next one. And then what we're going to say is if inventory item dot quantity is less than the max stack size. So at this point, we know that this inventory item is the same item we're trying to add. Now what we want to see is if the max stack size that this item has, if the current quantity on this particular item is less than that, then we can add to this stack, right? So for example, if its max stack size is 10 and this inventory item has 3, then we know that we've got 7 slots available on this particular item that we could fill in that stack. So we're going to say var original quantity. That's the original quantity of this item. So inventory item dot quantity. And then we're going to say inventory item dot quantity equals, and we're going to call the min function. We're basically going to say we want the least value out of these two, out of A and B. And our A is going to be our original quantity, so the original quantity that this item had, plus our remaining quantity. So for example, if we had 7 and the original quantity is 5, but the stack size is 10, we don't want it to be 13, okay? We want it to be the max stack size, and we want some remainder left over to add a new stack. So we're going to say original quantity plus the remaining quantity, or the max stack size. we want the least value of that, okay? And then what we're going to do is we're going to work out how many remaining items we have left to add. So we're going to say remaining quantity minus equals our inventory item dot quantity minus our original quantity. And that is basically going to work out how many items we have left to add to other stacks or to create brand new stacks with. Okay, and that is it for stackable items. Okay, now that is quite confusing. Please feel free to pause the video and read through this a few times just to make sure that you understand what's going on there. But basically, if the item is stackable, we need to loop through every single item in the current player's inventory and work out if there's any free space in those stacks to add some of the quantity that we've asked to add up in this parameter here, if we've got any space to add some of those items to. Okay, so if this item isn't stackable, then we need to loop through the remaining quantity and create brand new item stacks for that. And those stacks will obviously be 1. If it is stackable and we have some remaining quantity left over, again, we want to create new stacks up to the max stack size. So how we're going to do that is we're going to say while remaining quantity is greater than 0. So while we still have remaining quantity left, we're going to create a brand new item to add to the inventory. So we're going to say new item equals, and we're going to create a dictionary. To do that, you use these curly braces. And now we can provide some properties on this. So you'll see here before we use this item underscore reference, I'm going to create that here. I'm going to say item reference equals, and I'm going to provide a reference to the actual item that we loaded from the item database. And what that's going to do is it's going to allow us to always access this item reference, which will have all of the stats and all of the textures, meshes, whatever other properties you saved on the actual resource item itself. And we're also going to store the quantity here. So we're going to say quantity equals, and this is going to determine whether or not we can just assign the whole remaining quantity, or if we have to create a full stack and keep rolling over until we've added the remaining amount of items to our inventory. So we're going to say min remaining quantity and max stack size. Okay, and what we're going to do then is we're going to say items dot, let's just add a few lines here to the bottom just so I can scroll down enough for you guys to see. So we're going to say items dot append our new item, and let's reduce our remaining quantity, not spell that right, remaining quantity by the new items quantity. So however many we were able to add, let's reduce our remaining quantity by that. Okay, and once that is all done, we are going to emit our signal, inventory changed, and we're going to pass it a reference to ourself. And I've got a spell mistake here, it's new underscore item, not new items. And let's remove these new lines. Oops, let's remove these here, and let's save that inventory script. Okay, so this is the most complicated part of this entire tutorial. So again, like I've said a few times now, please, please, please pause the video, read through the script here, or if you are following along in real time, please make sure that you read through everything that you have on your screen. It can be quite confusing, I totally understand that. So hopefully I've explained it enough for you guys to get a grasp of what's going on here. If not, please feel free to leave a comment down below and I'll try and answer any questions that you might have. Now that we have our inventory resource, we want to add this inventory resource to our player. In order to do that, I'm going to come up to my player script. You might have a player script of your own, or you might want to add this somewhere else. So find an appropriate place for you to add this in your game. I'm going to add it to my player script. And underneath where I've assigned all of these variables here, again, you can ignore all of these. These are just part of my third-person tutorial. And let's just make a big space here just to clarify that this is completely separate. What I'm going to do is I'm going to say var inventory resource equals, and I'm going to load my inventory resource. So that is under res / and I saved it underneath the player folder. So player / inventory.gd. Okay, so that gives me a reference to this inventory resource. And then I'm going to create a brand new instance of that. So I'm going to say var inventory equals inventory resource, so inventory resource.new. And that is basically going to say for this inventory variable on our player, it is going to be a new instantiated instance of our inventory resource script. Okay, and that's going to give us access to be able to do things like player.inventory.addItem, .getItem, all the functions that we created in our inventory script here. Let's save this. And now what we're going to do is we're going to create a very easy way for our scripts, anything within our game, to access our player and also our player's inventory. To do that, I'm going to create something called a game manager. Now, you might have used something like this in the past. It's basically a global script, again, like our item database, that we can access from wherever we want in our game, so any script, and it's just going to allow us to do certain things. In this instance, it's going to allow us to access the player and its inventory, but you might have things that maybe you can add a score to the game or various things like that. They're really handy to have something like this, like a game manager, available in our games. I'm going to right click, I'm going to press new script, and we're going to call it game manager. Let's open it up. Let's delete all of this. Let's give it a class name. Let's delete all of this. And let's go into our project settings, and we're going to auto load this. So let's open it up, choose game manager. Let's add it to the list. And we want to make sure that it loads after our item database. We want our item database to be the first thing that loads. Let's close this. And now we're going to have a few things on this. First of all, I'm going to have a signal, capitals, signal, player initialized. Now what this is going to do is we're going to fire this from our game manager whenever this game manager gets access to the player within our game. And that's going to mean that things like UI can all subscribe to this signal, and as soon as there's a reference to the player, they can fire things up and go and get the player's inventory and do whatever they need to do with that player object. In order to get a reference to the player, let's do a func process delta. Now there's obviously a myriad of ways you could do this. I'm just going to do it this way. I'm basically going to say if not player, and we're going to have to create a variable for the player as well. So let's say var player above there. So if not player, so we don't currently have a reference to the player, then I'm going to call a function called initialize player. And then I'm simply going to return from this process function. So let's define that function here. So initialize player. And what we're going to do here is we're basically going to try and get access to the player within the scene tree. So let's say player equals get tree dot get root, and then we're going to say get node, and we're going to pass it in the path to where we would expect our player to be. So /root/world/player. Okay, so from here we're going to say if not player. So again, if we weren't able to find the player at this position, then there's nothing else for us to really do here. We're going to just return out of this function and wait until the player becomes available. If we have got past that part, then we've got a reference to our player within the scene tree, and we're going to emit a signal, basically saying player initialized. Okay, so our game manager now has access to a player variable. Everything that needs access to that can come over and grab that now. So let's also attach the player object itself to that signal, just for handy purposes. And now this is where we're going to start doing a few things. Okay, so we're going to load the player's current inventory from disk, and we're also going to save changes to the player's inventory to disk whenever it changes. In order to do that, we're going to have to connect to a player inventory signal that was fired from within our inventory script up here, this signal inventory changed. Let's go back to our game manager. So we're going to say player.inventory to get access to its inventory resource. We're going to connect to that signal, the inventory change signal. What's going to be responsible for dealing with that? Well, ourself. We're going to have a function on ourself called onPlayerInventoryChanged. And let's just carry on and define that. So let's say func onPlayerInventoryChanged, and we're going to pass in a inventory parameter, because remember, within our inventory itself, when we emitted that signal, we passed a copy of ourself in. And again, down here, you'll see we passed a copy of ourself into this. So we're going to take a copy of that inventory in our function. And for now, what I'm going to do is I'm just going to pass on this function. We don't really need to do anything right now. Once we start implementing the save and load functionality, then we'll implement that. So here what we're going to do is we're going to say var existing inventory equals, and we're going to try and load an existing inventory from the user's file system. To do that, we can use the user // special path, and this will be a path on Windows. It might be in your app data or your documents folder. So we're going to say user // and then we're just going to look for a file in there. So I'm going to say inventory.tres, which is the typical name for a resource file. And we're going to say if existing inventory. So if we found that file, then we're going to say player.inventory.set items, and that's the function that we defined earlier on. And we're going to call existing inventory.get items. Now we don't want to overwrite entirely the player's current inventory object with the one that we've just loaded. The reason we don't want to do that is that would break any connections to the signal itself, because this inventory variable would be a completely different object now, right? So this signal would completely break. So instead of just overwriting it, we're going to get all of the items out of the inventory that we loaded, and we're going to set them explicitly on the new inventory reference that we have within our player. That got set up whenever the func ready got called on our player. So we're just going to set all of the items on that new reference. If we didn't find an existing inventory, then you don't really need to do anything. But what I'm going to do is I'm just going to make a comment here. I'm just going to say, let's give the player 3 pieces of wood. Okay, so let's just give the player an item. So let's say player.inventory.add item. This is the function that we defined earlier. And we need to give it the name of a item. So for example, oak log. You'll see if we expand our items and double click on oak log, you'll see we give it a name of oak space log. And we're going to give him, let's say we give him 3 pieces of wood. Okay, and let's save that. And on our inventory player, on our player inventory changed, what we're actually going to do is we're going to save the current player's inventory to this file system location. So let's take a copy of that location. And to do that, we're going to use Godot's built-in ResourceSaver. So ResourceSaver.save, and we're going to give it the path user inventory.tres. And we're basically just going to pass in the entire inventory resource. What that's going to do is every time that signal gets fired, so a new item has been added or perhaps an item got removed, then this is going to get called, and it's basically going to save that entire resource to a file. And when you load up the game again, it's going to find that file and it's going to set those items on the player. So that's going to do full persistent inventory in your game. So this is great. But now we kind of need to visualize this, okay? So we need to see if this is even working. We've wrote a lot of code so far. Let's go and have a look to see if this is actually working. Let's go into our 3D scene. I'm going to create a new control node here. Let's start adding a bit of UI. So I'm going to create a control node. Let's just rename it to UI. I'm going to create another node. This is going to be panel. And let's move it down to the bottom. Let's size it up a little bit here. And I'm going to right click and add another child node, and this is going to be a grid container. And let's go to layout. Let's go to full rect. And let's just give it a bit of a margin here. So let's go 10, 10, minus 10, minus 10. Oops, minus 10. That's just going to give it a bit of padding inside this panel. And I'm going to attach a script to this. So let's go attach script. And you can call it whatever you want. I'm just going to call it inventory grid. Let's delete all of this here. And what I'm going to do now is I'm going to say func ready. And inside here, I'm going to get a reference to our game manager that we just wrote. And I'm going to connect to that player initialized signal. So player initialized. Who's going to deal with that? Well, we're going to deal with that ourselves. And what's the function name? We're going to say on player initialized. Okay, so that's all we need to do in our ready function. Let's define our func onReady on player initialized. We've got a reference to the player passed in. And here what we're going to do is we're going to get the player's inventory. So player.inventory. And now we're going to connect to the inventory changed signal. Again, who's going to deal with this? Ourselves. What's the function name? On player inventory change, just like we saw in our game manager. And now let's define that function. So on player inventory changed. Oops, player inventory changed. That gives us a reference to the player's inventory every time it changes. And what are we going to do here? Well, all I'm going to do is I'm going to loop through any item that's currently in the grid and remove it. And then I'm going to add a bunch of text labels into the grid that are basically just going to have the item's name and the quantity of that item currently in the player's inventory. So let's say for node in getChildren. So for n in getChildren, we're simply going to say n.queue_free. That is going to delete it from the hierarchy. And now for item in inventory.getItems, so for every single item within the inventory, we're going to say var item label equals label.new. And we're going to say the item label.text equals, and let's do some string formatting here. So let's say %s for a string, and let's say times %d for the number of items we have. Let's do our % here and give it some square brackets to provide the two variables for this. First of all, we're going to say item.itemReference. Remember, that gives us an actual reference to the full item resource. We're going to say item.itemReference.name, and then simply item.quantity, so how many are actually in this inventory slot. Finally, let's add the text label to this grid. So, item label, and let's save that. Okay, so if we play the game now, all being well, I know that was a lot of code, anything could have gone wrong here. If we play the game, we should see an inventory panel down on the left-hand side. And remember, in our game manager script up here, we said that if we can't find a current inventory for the player, we're going to give him 3 oak logs. So we're hoping to see 3 oak logs in that panel. Let's press play. And we have an error here. So we're saying if i.name equals item name. Okay, so the issue there was simply something to do with my setup. You probably won't experience this at all. There was some import files that I had left over hanging around from when I previously did this tutorial when I wasn't videoing it, and they got hung around, and it was basically loading null items from the file system here. So I went in and cleared those, and it's now all working fine. So you probably won't experience that. If you do, basically open your file browser here, and you can delete the import folder and let Godot re-import everything again, and you should be good to go. Okay, so let's go back to what we were trying to do. If we run the game now, we want to see that the player has 3 oak logs in their inventory. So let's press play. Fingers crossed, it all works fine. And great, we can see down in the left corner here now that we have 3 oak logs in our inventory. So let's actually, where we set the items here, so at this point here, we know that the inventory is saved to the file system. Let's try and add a few new items to the inventory. So let's say player.inventory.addItem, and we're going to say oak log again. This time, let's say 1. So we're expecting now that it's going to come in, it's going to hit this if statement, it's going to load the existing items, which is 3, and then it's going to add another one to that, which should be 4, and it's not going to run this again, so it's not going to give them another 3. So we're hoping that they end up with 4 items. Let's press play. Fingers crossed this all works. Great, we have 4 oak logs in our inventory, so we know this is working. Let's remove this from our code here. Let's save this. And now what we're going to do is we are going to create just a simple item that the player can run into and pick up, just to demonstrate how we would use this in practice within a game in an environment where we have items on the floor, collectibles, coins, for example, that the player can run into, and we would trigger this player.inventory.addItem code. You can use this now for anything from basically anywhere you have a reference to the player. You can call inventory.addItem and give it any name of an item that you create in here. So you can duplicate these to your heart's content. Let's say we had I don't know, let's say a pickaxe, for example. Let's duplicate that there. Let's go into here. Let's rename it to pickaxe. Oops, pickaxe. It's not stackable. We've got 1. Perhaps it's a piece of equipment. It might have a mesh attached to it. we can basically now just say player.inventory.add-item pickaxe. Oops, pickaxe, let's give him 1. We know that this isn't going to fire actually because there is an inventory saved to the file system. So let's run it in here and let's press play just to make sure that that works. And you can see now we have a pickaxe. If we close this and remove that line of code, we're no longer adding the pickaxe anywhere in the code here. So let's run this again, make sure it's still there. We still have that pickaxe. So yeah, let's go and create a little item that we can collect within the world itself. I'm going to come up to the top here. I'm going to create a new scene. It's going to be a 3D scene. And we're going to change the type of this 3D scene. So let's go to change type. I'm going to change it to an area. Let's rename it to magic orb. And we're going to create something that allows the player to pick up this magic orb item. So again, we get this little warning triangle. It basically says there's no collision shape here. First of all, though, what I'm going to do is I'm going to add a child, which is going to be a mesh instance. And let's come over to the mesh here and choose a sphere. And I'm going to come to the transform and I'm just going to scale it down to 0.1 on all the axes, just so that it's small. Let's give it a bit of a material as well. So let's come in and apply a spatial material. Let's give it a bit of a color. I don't know, let's go for something like this. And now let's come over to our magic orb and let's add a collision shape. And it's going to be a sphere. Now we can keep it at that size. We don't want it to just be the tiny little sphere here that the player has to run into. I think leaving it at quite a big size is good. And now what we're going to do is we're going to attach a script to this. So let's say attach script. Let's just leave it like that, magic orb, that's fine. Let's remove all of this. And let's save it as, we don't want to save it in the items folder. Let's just save it to our root scene for now. So magic orb. And now what I'm going to do is I'm going to come back to where it says magic orb here. I'm going to come over to node and I'm going to attach to this body entered signal. So let's double click on that and let's connect it to our root element. So connect. And now we're going to have this on magic orb body entered. So what are we going to do here? Well, we're basically going to have something really, really simple that allows the player to pick up this item whenever they run into it. We're going to say if body equals and now we can basically say, well, is this body the player? And we have access to the player on our game manager. So we can say, if the body equals game manager.player, then we know that the thing that ran into this was the current player. So what we're going to say there is we're going to say game manager.player.inventory.add-item. And let's give him or her the magic orb. Let's give him 1. And let's just delete this from the scene. Let's just say Q3. Save that. Let's come back into our 3D scene. Let's go back to the main world. Let's collapse all of this. Let's find our magic orb scene and let's drag it into the scene there. Let's not have it as part of the grid container. Let's just drop it in the world. And let's move it up a little bit here. Let's just double check that that is actually sitting on the floor nicely. Okay, let's put it up a little bit. And let's Control D to duplicate. Let's add a couple more of these into our scene, just so that we can test this out a little bit. And let's hit play and let's see what happens. Okay, so we have 4 oak logs in our inventory. We have 1 pickaxe. And I'm going to run into this. You'll see now we have a magic orb. Let's run into it again. We have another magic orb. Remember, we made this non-stackable. And let's run and pick all of these up. Okay, so we have 4 magic orbs, non-stackable. Let's close this and reopen the game. And now we still have those 4 magic orbs. Let's try changing our magic orbs to be stackable. So let's go to our items, magic orb T-res, come over to the inspector, let's choose stackable, yes. And let's create a stack of, let's just say 3. We can stack 3 magic orbs together. Let's press play. We're going to have the 4. They're not stacked because they were saved to the inventory before they became stackable. So you could go further and have something to allow you to drag items onto each other and stack them together. But in this instance, what we want to see is when we collect all 4 of these, we want to see them get added to the existing stacks. So let's run into this. You can see we have magic orb times 2. Let's run into this one, magic orb times 3. Now we're hoping that this one rolls into the next stack. And it does. We've picked both of those up and it's filled a new stack. And that is everything for today's video, guys. I know this was a long one, and I know it was really quite complicated in parts, and I apologize if I didn't explain it well. There were some parts that you just had to pause the video and read through several times to really get a grasp of it. Like I say, please leave comments down below if you are struggling. I'm more than happy to answer any questions that you might have. Thank you so much for sticking with us for this one. If you enjoyed this tutorial, please make sure to click on that subscribe button if you haven't already, and hit that little notification bell to get notified whenever I release new content. I'm releasing new content every single week, and just a reminder that I have actually changed my release schedule to be a Friday afternoon rather than a Monday morning, just due to life circumstances. It gives me a little bit more time during the week to work on these tutorials for you guys. As always, thank you so much for watching, and I'll see you guys in the next video.